Right, so video 6 we're going to go through actually using the cement transducers, the operation of them, how they work and how to use them in cutting PMMA. Now we've got a proper clinical PMMA cement filling a bovine femur section here. Obviously size is not relevant to human femurs, but it does give you a feel for the two materials. In vitro bone and the PMMA cement bonded to it. Okay, so we've set up TORS with two cement transducers, both in hand pieces. There's an 8mm piercer in this one and an 8mm scraper in this one. We'll start with the piercer. As in the previous video, setup generator has booted and it is in standby with 3 channels illuminated. Cement transducers plugged into channels 1 and 2, the yellow cement transducer channels. So first press of the switch selects the channel that we're connected to. You can't tell whether you're in 1 or 2, but by pressing the button you are told by the generator. Now we've got the foot switch set up as well, so just for convenience while I'm doing this, I will probably use the foot switch instead. Now obviously that has channels 1 and 2 as well, and we're using channel 1, so I press 1 and it's activating because it's already selected. This is now resonating. Okay, that's the operation of the cement transducer. Now a quick word about the vibration mode of TORS. Conventional cement cutting ultrasonic systems use what is called a longitudinal vibration mode. The vibration is backwards and forwards along the axis very quickly, 28,000 times a second. TORS is different because it's using a combination of a longitudinal mode but also a different mode called torsional, which is a twisting motion. You may not see this, but the probe is actually rotating a little way, through a little angle, backwards and forwards around the axis. So it's actually twisting like that, as well as vibrating like that. This is called an LT mode, longitudinal torsional. The result is that this softens the cement more quickly than a conventional system with the same number of watts of power. That's a very important difference between the two types of system. Okay, so that's why TORS is working the way it is. Now here we have the bone with the cement, and like other systems, you just press the tip into the cement, activate, and the energy delivered to the cement softens it very quickly, and the probe sinks through the softened cement. And you pull it out, and while it's still warm and soft you can break it up. This is how the piercer works. Pushing in, not much force, let the ultrasound do the work, switch off, pull it out, and there's a great slug of cement on it. So as in all ultrasonic cement removal systems, when the probe touches the bone, the ultrasound is not absorbed by the bone, it's reflected by it because the impedance is very different to cement. And the probe merely rattles and screeches against the bone. That's a very important indication of bone contact, and the surgeon uses that all the time as an indication, and it's important to use that feature. Now we've got a section bone here which will work very well to demonstrate the scraper. So I'll pick up the other transducer already fitted with the scraper probe. Now if I press the switch on this handpiece, selects the other channel, so it's connected into 2, and then we straight away move into cement scraping now. And this obviously works by pulling back peeling back a big slug of softened cement, which can be plucked off, and in you go again. And again, you hear the screeching. Probe contacts the bone. And as with the piercer, use the syringe full of saline after each set of 3 scoops, and you pull all of that saline out again so that it's dry. You don't want saline left in there because the ultrasound can actually boil that saline, and that might do some thermal damage. It's all very easily put in and removed with the suction lavage system. The only other thing to mention is the different sets of probes. We have 4 piercers, 4 mil, 6, 8 and 10. They all have holes in them for catching the extruded cement, except the 4 mil piercer, which is solid because it's so small. That is very specifically for piercing through very hard, low friction plastic cement plugs at the bottom of the cement mantle. And looking at the scrapers, there are 3 sizes of scraper: 6 mil, 8 mil and 10 mil. And these are quite unlike conventional systems. They're flat fronted because they are just going in and scraping back. And also they have these little torsional serrations on the underside flange. That is using the torsional element of the vibration to help deliver the energy more efficiently.